And now we talk about the Copernican revolution. This is, of course, the time when finally the geocentric model of the Greeks and of Aristotle is put to bed. Copernicus proposed a sun-centered model that was published on his death in 1543, and he used this model to determine the layout of the solar system and planetary distances. Now, in practice, this model was no more accurate than Ptolemy's in predicting planet position, since it used circular orbits. So it's an important question in terms of scientific method to ask why this idea persisted, since new and better theories are supposed to fit the data better, according to the archetype of how science works. Copernicus was not only the first modern astronomer, he was also the last ancient astronomer, so he's a transitional figure in the history of science. We can see the backdrop to Copernicus in growing anti-Aristotelian sentiments and a challenge to the authority of the Church. Humanism was abroad in the world as the world became richer, having come out of the vice of the Dark Ages and the medieval times. Among thinkers of many kinds, there was an increasing belief in the underlying mathematical structure of reality and the fact that it was amenable to rational thought. And so we come to Copernicus. He was born to a prosperous family in Poland, studied at the University of Krakow, and enrolled in Bologna to study canon law. He essentially drifted into astronomy, but he was good at it, and so soon he was lecturing in Rome. Then he enrolled in Padua to study medicine, and eventually got a doctorate in canon law from Ferrara. So he moved around. He was voracious in his interests and his knowledge, and he studied different things. Copernicus was very well read in astronomy. He'd read the Greek Alphonsine tables, which were the best version of astronomical knowledge to come out of the medieval time. He was employed in the church. He spent his life as a canon in the cathedral at Varmia, where his uncle was a bishop. That's quite a high post, and so his time was taken with clerical duties, and he only did science when he could. The broader backdrop to his life is the Reformation. Martin Luther's theses were pinned to the door of the church in 1517, and then the backlash of the Counter-Reformation with the Council of Trent in 1545. So these were very turbulent times. Here's Frombork Cathedral, which was home to Copernicus from 1512 till near the time of his death. This book of Copernicus was never published. It contains 7 postulates: the idea that bodies do not all move around a single point, the center of the Earth being the center of gravity and of the moon's orbit, the celestial spheres orbiting the sun, which is near the center of the universe, so we have the heliocentric idea, the distance from the Earth to the sun being much less than the distance from the sun to the stars, and so stellar parallax, or the variation in the angle between stars and their relative brightness over a year, is not observed. This is a critical point because it's the main objection to the Earth moving from the Greeks. The idea that the stars are immovable and their apparent rotation is due to the rotation of the Earth. And the idea that the Earth moves in a sphere around the sun and it has more than one motion because it's spinning as it revolves around the sun. Also, the fact that the Earth-Sun motion relative to the planets is responsible for their retrograde motion. So this book, never published in 1514 as a manuscript, is a precursor to the revolution that would follow. He was developing these ideas actually for several decades. The book that he's famous for is called De Revolutionibus. It was his major work. It was completed just before his death, but the first draft was written 13 years earlier, and a major question is, why did it take him so long to publish it? I think we know the answer. Copernicus was not a professional astronomer. He had many other duties, and it was a turbulent time. At the time in his city, they were fighting the Teutonic Knights and King Gustav of Sweden, from a neighboring country. He actually had to do military duty as well as religious duty, so he was pretty busy. He was also unsure about the correctness of his model. There were discrepancies because, as we've seen, the model didn't do any better than Ptolemy's in predicting the positions of the planets. But probably most important of all, he was worried about the controversy behind the claim that the Earth moves, because to everyday opinion, echoing the idea of Aristotle, it seemed a ridiculous idea. And clearly, in terms of the theology of time, he was running against the teachings of his own church. Here we see a picture, a recreation of Copernicus. His body was disinterred a few decades ago, and they did a genetic analysis and a reconstruction. So we have a pretty good idea that unlike the pictures you might see in paintings, this is what Copernicus actually looked like. Here's the picture that changed the world on the left. Sol, the sun at the center, and the Earth and the planets moving around the sun. A simple change of perspective from an immobile Earth with everything revolving around it to an immobile sun with everything revolving around it. Yet it was profound. And here we see some quotes from the first page of the first edition, printed by Johannes Petreius and published in Nuremberg in 1543. You have in this recent work, studious reader, the motion of both the fixed stars and the planets restored from ancient as well as recent observations and equipped with new and admirable hypotheses. You also have the most expeditious tables from which you can easily compute the positions of the planets for any time. Therefore, buy, read, and profit. Copernicus's heliocentric model, as I said, had to posit the stars as being very far away. And there's the question of us not feeling the motion. So we have the sun at the center, the Earth just one of the planets and not special. The inferior or inner planet orbits are closer to us than the sun. And retrograde motion occurs when we lap or pass faster on the inside of the orbits of the superior or outer planets. And then the stars are all attached to an outer celestial sphere. This universe is finite, but because the Earth is in motion and no parallax is seen for the stars, it's much larger than Ptolemy's universe. The best estimate of the size of a Copernican universe would be about 1 billion miles across. Now that's a fraction of the size of our real solar system, but it was a pretty prodigious number for his time. Why was replacing this on the left, the Aristotelian Ptolemaic model, with this on the right, the Copernican model, so revolutionary? In part, a cultural reason, because moving the Earth from the center to creation challenges not astronomy, but it challenges culture, religion, and our self-image. Why was the appearance of the stars, their brightness and parallax, such a major distinction between the geocentric and heliocentric models? We can see in these two diagrams what's going on. In the geocentric model, the celestial sphere rotates around the Earth, so all stars are automatically at a fixed distance, so they never change their brightness or relative positions, the phenomena of parallax. But in the heliocentric model, the Earth is in motion relative to the outermost sphere of the stars. So there's only a lack of parallax if the stars are so much further away than the planets that these small changes in relative brightness and angle as the Earth moves in a yearly orbit are negligible or undetectable. And that makes for a very large universe. Here's a diagram of how parallax works in an exaggerated form. As the Earth moves around the sun, a nearby star, with respect to more distant stars, appears to shift its angle. You can get the same effect by holding a finger in front of your nose, close to your face, and looking at a distant backdrop with one eye and then the other, where the left eye then the right eye represent the Earth on either sides of its orbit. The further you move your finger away from your nose, the smaller the parallax effect. And so you can imagine far enough that that angle will be hard to detect. That was the size of the Copernican universe. From Ptolemy to Copernicus, Copernicus had held to a 1700-year tradition that celestial motions were circular. This was a theme of Aristotle and the Greeks that he wasn't brave enough to look beyond. We'll see that Kepler was. As a result, he had to add many epicycles to match the observed non-uniform motions, which is to say that the planets do not move at the same angular pace across the sky from one night to the next, and observations were already good enough even before the telescope to show this. So his model was more elegant and it was simpler, It was definitely elegant in explaining retrograde motion, but it was not more accurate than Ptolemy's. And so, Copernicus was the author of a slow revolution. As astronomers got to use his book, they had a practical tool for predicting celestial motions. But they used it despite and not because of the idea of the Earth's motion, because as I said, it wasn't more accurate than what came before. There were only 276 copies of the first edition, which is a very similar, slightly larger number to the number of Shakespeare's first folio that were printed. The Revolution's book never went away. It was a starting point for Copernicus and Galileo. Copernicus, hedging his bets against the problem he might experience with the Church, he had a built-in defense. He tried, essentially, to make the book unreadable for non-astronomers. Mathematics is for mathematicians, as he said. And in fact, his book on the revolutions has only 4% of its length containing discussion of the heliocentric hypothesis. The other 96% is dense mathematics and celestial astronomy for predicting positions of the stars. This is not a bestseller by any means. Also, in an introduction to the book by Osiander, the statement was made that the heliocentric hypothesis is just a device of mathematical astronomy. In other words, it's not real. Don't get too worried about it. Don't take it too seriously. That's the end of this topic.